Good evening once again. Sorry, it's good night almost. I was away on some personal work and hence I was not able to record in the evening. Anyway, I don't want to go to sleep before recording today's lectures. So I thought, let me continue my usual procedure. Okay, it's night 11:15 and let me at least try my best to finish up at least today's cup of tea. Okay, so now the problem here is once again on the conservation of momentum. So the question is something like this: two persons each of mass. Okay, so his mass is m, his mass is also m. The cart mass is capital M. Now what happens is the person on the left jumps to the right, left jumps to the left. So this person jumps to the left with a velocity u, and then so because he jumps, the cart now starts moving like this with a velocity v. Okay, definitely it has to move because there's no friction here. Now, as this is moving, this person will also jump like this with the same velocity u. Like the way how he had jumped, he is also jumping with the same speed. So, as a result of it, now what will be the velocity of the cart? This is the question. Now, the student response given here is since both the persons are jumping from the same speeds, the cart will come to rest because when he jumps, it moves with the velocity u v, and when this fellow jumps, so definitely the cart should be imparted the same velocity backwards because the distances from the ends are same and they are jumping down with the same velocity. So definitely the cart should be given an opposite velocity v. Since already moving with the velocity v, now you are applying a brake, okay, with a negative velocity v. So this vector and this vector will cancel each other, and hence the student says that the net speed equal to 0. This is a misconception. Let us understand why it is a misconception. There are problems like this which appears to be very simple, and the moment we read the question, we immediately jump to a conclusion saying that yes, this could be your answer. But many times we need to work it out, logically reason why this will not be your answer. Okay, now let us work on this. Now towards it, when this person jumps, I had said that the cart along with the second person is now moving with a velocity v. Let us apply our conservation of momentum. What does the conservation of momentum say? It tells you the initial momentum before he jumps. What was the initial momentum? See, this was at rest, he was at rest, he was at rest. Though there is a wheel, okay, it's not moving anywhere. It is initially at rest. So initial momentum was 0. Then final momentum. Now, what is final momentum? See, this person jumps to the left over here, which means let us say anything that moves in the right is positive and everything that moves in the left is negative. So I will take this as minus m into u. Momentum is negative over here. Minus m into u. Okay, momentum of this person. Now, since he jumped, then the cart along with this man was started to moving at the velocity v. Definitely, this velocity is not equal to this velocity u. Okay, let us assume this velocity is v. So therefore, now so the momentum is positive here. Why positive? Because you see the cart is moving in this direction. The velocity is positive. Momentum is nothing but mass multiplied by velocity. So definitely it should be positive. Okay. So I'll write m plus m multiplied by v. Okay. So 0 equal to so much. In other words, I can get the velocity value. The final velocity of the cart plus the man should now be equal to m divided by m plus m into u. Let me call this equation number 1. Next, now the cart is moving here. Now suddenly this man, he jumps with a velocity u. Okay, so what can happen? The cart should slow down. Why cart should slow down? Because you see he's moving like this. So as a result of it, okay, there should be a recoil velocity. The same thing that you do, right? Okay. So now what happens here? Apply the same conservation of momentum once again. So when he was not jumping, okay, then what was the momentum when he did not jump? What was the momentum? The momentum was nothing but m plus m into v. This was your momentum. This is momentum before this person jumped. Now when the person jumped, now what was the momentum here? This is already moving at a velocity v. In addition to it, this person is moving down in the velocity u. It means the net velocity of the particle to an external observer is nothing but m into u plus v. Do you agree with this statement? See, it's very simple. See, you are jumping from a stationary bus. Okay, you're standing on the footboard of a bus. Bus is not moving. Okay, now what you do is you jump in the forward direction with a speed equal to, let us say, 1 meter per second. Okay, now what is your velocity to an external observer? 1 meter per second. Now what you do is the bus is already moving. Then let us say bus is moving at a speed of 2 meter per second, and you are jumping with a speed of 1 meter per second relative to the bus, not to the observer, relative to the bus. So therefore, what is the total speed as measured by an external observer? That is one who is standing on the ground. He will say, "Arey yaar, pagal hai tu? Hey, bus is already moving at 2 meter per second. You are also jumping. You will get hurt." Otherwise, he will say, "See, I am just jumping with the same speed. How do I get hurt?" You get hurt because bus is aiding your velocity, right? Bus is aiding your velocity. So you definitely get hurt. So 2 plus 1, 3 meter per second is your total speed now. Okay, that's what I have done. 2 plus 1 here. I hope you understand this. Okay, now after this person has jumped, now this velocity now changes. What is this velocity? Now the cart, I do not know what is the cart velocity here. Okay, whether the cart is still moving the forward direction or in the backward direction. So I will not be able to guess what is the sign of it. So I will just write plus m only. Plus m into, I do not know what is its velocity. Let me say v dash. I still don't know whether v dash is 0. Okay, because as the student said, v dash may be 0, v dash may not be 0. I just put it as v dash. Okay, because until and unless I am not conclusively giving a statement, mathematically proven, I cannot say anything. Okay, now what we do is, let us simplify this. mv plus mv is equal to mu plus mv plus mv dash, right? Now you have an mv here, we have an mv here. We'll cancel these two. Now we have this. Now I will write m into, you already know the expression for v. What is v? M divided by m plus m into u should now be equal to mu plus mv dash. I'll pull this mu on the other side because I want for this v dash here. Okay, what is the net velocity? Okay, so therefore, now what do I have? I will write it here. This implies, it continues here. So now this should be m divided by m plus m into u minus m. I'll take u common here. Minus m into u is equal to mv dash, right? So which means that this should now be equal to mm minus m square minus divided by m plus m is equal to mv dash. So this minus and plus goes away. And what am I left out here? I am left out with this. In other words, I can now write v dash is equal to minus, hey, I'm missing something. I missed this value of u. This is the value of u minus m square divided by capital M into m plus m into u. So definitely the cart is moving backwards. Agreed. Okay, the moment the second person jumped, cart is moving backwards. But okay, the velocity is not 0. See, the net speed is 0. That's what it says, right? Which is incorrect. Okay, I hope you understood the concept. Now, what was the misconception here? The misconception was about understanding the relative motion of a person. Okay, when a cart is moving, when you are discussing about speeds, you are in kinematics, you always discuss speeds with respect to a stationary observer. You are standing somewhere, a particle is either moving towards you or moving away from you. But there are places wherein you should describe kinematics based on the relative motion. That means you are an observer, you are also moving. Okay, the person before you or behind you is also either moving towards you or away from you. So if you understand the relative velocity or relative term concept, definitely you will be able to solve many problems. Okay, so with this, I hope you like this video. So do like, share, and subscribe to my channel for more updates. And you can also put me across what are the different kinds of problems you would like to look into. So definitely I would like to see to it that such kinds of videos can be uploaded. Thank you, friends, for watching this video. Do like, share, and subscribe to my channel for further updates. Thank you.